So I got cut off there. But it's about ready to talk about an example of how you can use a family to help you find missing side links without necessarily having to go through Pythagorean theorem. So, for example, we've got this 7, 24, 25 family, right? Well, if we know that a leg is, say, 21 feet, another leg is, 52 feet, and we want to go find how long the hypotenuse would be. Well, we know that if we divide 21 and 52 both by 3, then we get 7. So I'll try this. We can factor 21 into 7 times 3. We can factor 52 into 24 times 3. So that's 21 and 52 have the same factor shown, right? Well, that means that 7 and 24, those are the legs of a Pythagorean triple. So then we know that the hypotenuse would have to be 25 with the same factor applied to it, 25 times 3. And 25 times 3 is 75. So therefore, the hypotenuse would have to be 75 inches or centimeters or whatever. Okay. Now, granted, it's a little tough to use triples, but if you can recognize the patterns, then it can be a faster way to find missing side links. That being said, Pythagorean theorem will always work. If I know that two sides of a right triangle are 21 and 52, then I know I can use Pythagorean theorem to find the third side. Okay? All right. So let's stop for a second. There is one more page of information to get to, but let's stop for a second and do a couple of quick examples. Right? We've got enough to come in here and do some examples. So, I'm going to bypass some of this stuff. In your example packet, the first example, you have 3 examples here. First one is, how high up on the wall will a 20-foot ladder touch if the foot of the ladder is placed 5 feet from the wall? Take a look at that and see if you can't figure out how far up the ladder will touch. Okay, got it? Well, here's the deal, right? A wall is going to be perpendicular to the ground, so of course there's going to be a right angle here. So we're in a right triangle. Anytime you know two sides of a right triangle and you want to find the third, you can always use Pythagorean theorem. So this guy right here is what we want to find. And so Pythagorean theorem, which says leg squared plus leg squared equals hypotenuse squared, means that we're going to take x squared plus 5 squared and set it equal to 20 squared. So we get x squared plus 25 equals 400. Subtract 25 from both sides, and x squared equals 375. Now, square root and square root means that now I got to find a way to reduce the square root of 375. Again, I like this upside down box still. If you like factor tree or finding perfect square numbers that will go into 375 and using that, any method is fine as long as you get it reduced correctly. So I'm going to take 5 into 375, which is going to go 75 times. Now, since I used 5 before, and 75 is not prime, so I'm going to put a box around it. Since I used 5 before, I'm going to try to use 5 again to keep my factors lined up. 5 will go into 75, and it will go into it 15 times. 15 is not prime, so I'm going to put a box around it. I'm going to keep using 5 as long as I can. 5 will go into 15 3 times. Now, 3 is prime, so I'm not going to put a box around it because 3 becomes one of my factors. Now, I need pairs. So there's a pair of 5s. Remember, it takes 2 to break one out of jail because this one guy gets shot. The other guy actually gets out. So 5 is going to get out of jail. Jail being the radical. This 5 and this 3 don't have a buddy to help them. So 5 and 3 have to go back in. You multiply them when they go back in, and you get 5 radical 15. So the ladder will reach up 5 times the square root of 15 feet high. which of course you would multiply out and get some decimal to make it more sense in a real life setting. But again, for now, we're preparing for Algebra 2 and pre-calc by reducing our radicals. Okay? Next example. Right? We want to find the area of this rectangular rug if the width is 12 feet and the diagonal measures 20 feet. Now your notes, your example packet already gives you the missing measure here, but you weren't supposed to have that. So let's pretend like we don't have it, right? To find the area of a rectangle, of course, that's length times width. Well, the length is 12. The width, we theoretically don't know. But it's a rectangle, so this is definitely going to be a right angle here. This diagonal, the diagonal of a rectangle, also plays the part of the hypotenuse for this right triangle. So we can use Pythagorean theorem to find the missing leg over here. Leg squared plus leg squared equals hypotenuse squared. So we get x squared plus 144 equals 400. X squared equals, right, this is going to be 256. Now square root, and x ends up being 16 feet. So now we just take 12 times 16, right, and we get 192 feet squared. Okay? So again, uses of the Pythagorean theorem. Anytime you have two sides of a right triangle and you want to find the third, Pythagorean theorem is the way to go. Okay? Next example. Okay, so find the area of an isosceles triangle, and you have some measures here. Now, there's a trick to this that we've mentioned before, but not in a lot of detail and not very often, and didn't spend a lot of time talking about it. So we ought to pick it up again here. Okay? We're going to find the area of an isosceles triangle with side lengths 10, 13, and 13. Well, anytime you don't have a decent picture to go off of, you ought to draw one. So that's what I'm going to do. If it's an isosceles triangle, then these sides are the same. So this has got to be 13, and this has got to be 13 meters. And this whole side here is 10 meters. Now, want to find the area. How do you find the area of a triangle? Well, it's 1/2 base times height. Well, we know the base of that isosceles triangle is 10. The height is got to be this guy right here. It's got to be this imaginary segment coming from the vertex and perpendicular to the opposite side. Height's always at a perpendicular. In other words, an altitude. Right? That will tell us the height of this triangle. Height is always at a perpendicular. Well, when we draw this altitude in, we create two smaller right triangles inside of it. Now, because base angles are congruent in an isosceles triangle, and this angle is 90 degrees, and so this angle is 90 degrees, by angle, angle, side, we've got two congruent triangles, which means that this side and this piece are going to be congruent as well, which means that this piece is going to be 5 meters, and this piece is going to be 5 meters. Now we need to know that because I'm trying to find this height. And this height is also the leg of a right triangle. Now I've got the other leg and the hypotenuse, and I can go find h. Leg squared plus leg squared equals hypotenuse squared. So h squared plus 25 equals 169. We subtract 25 from both sides. H squared equals 144. Square root, and so h is 12. So the height is 12 meters. We can plug 12 into our area formula here. Half of 10 is 5. 5 times 12 is 60, and so the area is 60 meters squared. Okay? It's the idea that the altitude bisects this base of an isosceles triangle that I was referring to before. That's always true. An altitude will bisect, an altitude drawn from the vertex angle of an isosceles triangle will always bisect the base. An altitude drawn in an equilateral triangle will always bisect the opposite side, always. Okay? So that was the trick to this example. One more involving Pythagorean theorem and triples, and that's this, right? We want to be able to find the length of the hypotenuse of this right triangle. Now, we can use, now this says find the length using two methods. We know we can use Pythagorean theorem, and I don't want to go through that. We've done that a couple of times here already. What I would rather focus on is the fact that 10 and 24 both have a common factor of 2. Right? 12 times 2 would get me 24, and 5 times 2 would get me 10. So that means 10 and 24 could belong to a Pythagorean triple family. Well, 5, 12, and 13 are a Pythagorean triple family. So what I got to do now is to find x is apply the factor of 2 to 13. And so x here has to just be 26. That's by using the Pythagorean triple method. Now again, you can certainly go in and do 24 squared plus 10 squared equals x squared and go through the arithmetic, but you're going to find that x is 26 this way as well. Just a little shorter way of doing it. Okay? All right. All the things that you need to be able to do with the Pythagorean theorem and Pythagorean triples. All right? All right, let's back up for a second. We've got one other page that we want to fill into our book here. So you need to have your book. And the page is all about the converse of the Pythagorean theorem. Okay? The converse of the Pythagorean theorem, it says, if 3 segment lengths satisfy the Pythagorean equation, or the Pythagorean theorem, then they must form a right triangle. Okay, and that's that simple. We've got 3 side lengths. 1, can they make a triangle? 2, will they form a right triangle? And so the first example here on the left that I want to focus on are these 3 segment lengths, 8, 17, and 15. Okay? First of all, can they even make a triangle? And you need to think back to last semester where we talked about the triangle inequalities. And one of the things that we talked a lot about was that any 2 sides, the lengths of any 2 sides in a triangle need to add up to be bigger than the third side in order to make a triangle. Now what we shortened that down to was check the 2 shorter sides and make sure that they add together and to form something longer than the third side. The 2 shorter sides here are 8 and 15. 8 plus 15 is 23. 23 is definitely bigger than 17. So we can make a triangle. We just need to plug it into the Pythagorean equation and see if it works. Now, what would be the hypotenuse if this were a right triangle? Remember, the hypotenuse is always the longest side. So the 17 would be your hypotenuse. These other guys would have to be your legs. So that's how you know where to put which number in the Pythagorean equation. So 17's got to go by itself. The biggest side, longest side, is going to go by itself. And then the other 2 go on the other side of the equation. So we get 8 squared plus 15 squared equals 17 squared. Well, 8 squared is 64, 15 squared is 225, and 17 squared is 289. 64 plus 225 is 289. 289 does equal 289, so yes, 8, 17, and 15 would definitely form a right triangle. Okay? What about the next example here, 12, 35, and 36? First, check to make sure it makes a triangle. 12 plus 35 is definitely bigger than 36, so it will make a triangle. Question is, will it be a right triangle? Well, 36 would have to be the hypotenuse, so it has to go over here by itself to be squared. So we get 12 squared plus 35 squared equals 36 squared. And you can see the arithmetic there. That'll get us down to 1369 equals, and I've made a mistake here, 1296, which is not true. 1369 does not equal 1296. So that means that these three side lengths, these three segment lengths, are not going to form a right triangle. Well, the converse, the Pythagorean theorem, actually takes that a step further and says, or farther, and says, okay, fine, it doesn't make a right triangle. There are a couple of additional addendums to that that will let us know what type of triangle it actually will form. Now, since we're talking about a right triangle, we're talking about types based on the angle measures. So what other types are there? Well, there are acute triangles, and there are obtuse triangles, right? Well, believe it or not, checking to see if this satisfies the Pythagorean equation will give us some insight into whether the triangle is an acute triangle or an obtuse triangle as well. We're still going to take the longest side and square it. We're always going to take the longest side and square it by itself, okay? But the addendums that I'm talking about, or the theorems that sort of are related to this, say this. Well, the converse says, of the Pythagorean theorem, says that the longest side squared is equal to the short side squared plus the medium side squared. That has to be a right triangle. If they're equal, then it's a right triangle. Okay, that's how we get right triangle here. But if the longest side squared is greater than the short side squared plus medium side squared, then that gives us an obtuse triangle. If the longest side squared is bigger, is greater, then that's obtuse. Obtuse angle bigger than 90, longest side squared bigger than the other means obtuse. If now, on vice versa, or on the other hand, if the longest side squared is less than those other two squared and added together, then that triangle's got to be an acute triangle. Okay? And that's how I remember it. Acute's less than 90, longest side squared less than the other guys, then it's got to be an acute triangle. So, what's happened up here in the second example? So they're not equal, but what we do find is that the longest side squared is less than the other two. So this triangle must be not obtuse, but acute. Okay? And that's all there is to the converse. A couple of quick examples in here for you to look at. Okay? Classify the triangle with the following leg lengths as acute, obtuse, or right. Now this is in your example packet. Take a look at these two. The two previous examples are also in your example packet. These are the third and fourth example. So give these a shot, see what you come up with. Okay, so your two examples. If we're going to try to see what type of triangle these side lengths create, then we have to be able to identify the hypotenuse first. There's the hint there. The square root of 8. What is the square root of 8? Is it indeed longer than 4 or 6? Because we need the longest side to be by itself. Well, the square root of 8 is somewhere in between 2 and 3, right? 2 squared is 4, 3 squared is 9. So the square root of 8 would be somewhere between 2 and 3, so probably 2.6 something right around in there. Well, since it's like 2.6 something, or somewhere in that area, that's definitely going to be shorter than both 4 and 6. So it's not the hypotenuse, which means that 6 has to be the hypotenuse. Or, I don't want to call it the hypotenuse. I mean, I know this says identify the hypotenuse. But 6 is going to be the longest side. So we got to do longest side squared and see how it's related to the other two sides squared and added together. Well, 6 squared is 36. 4 squared is 16. The square root of 8 squared. Squares and square roots cancel each other out. So we get 8. So this is 36. 16 plus 8 is 24. The longest side squared is bigger than the other two. So this has to be an obtuse triangle. Okay? Not to mention, we should have checked to make sure that this even makes a triangle. And since the square root of 8 is 2.6 or somewhere right around that area, you add that to 4 and you definitely get something bigger than 6. So it will make a triangle. Okay? So the same thing for number 2. And if you haven't done it yet, you can stop the video, work it out, and then see what happens. Okay? All right, so the longest side is obviously 28. It's not just automatically the guy at the end. Look at the 3 numbers. 28 is obviously going to be the longer side. Okay? Now, can we make a triangle? Well, the other 2 sides add up to be bigger than 28. Well, 20 plus 21 is 41, definitely bigger than 28. So now we go check our Pythagorean equation. 28 squared, how is that compared to 20 squared plus 21 squared? Right? So 28 squared is 784. 20 squared is 400. 21 squared is 441. So now we've got 784 and 841. So longest side squared is smaller than the other 2 squared and added together. So that means that this triangle must be an acute triangle. Okay? And that's all there is to it, folks. Homework is out in Canvas. Make sure you get that done by next class.